Hey guys, lesson 18, day 2. We didn't finish it, and so I want to make sure that I had a chance to talk to you about this example, building an exponential formula, building an exponential function based upon the different features that you needed to know about. And so if you will, I'm on the bottom of page 12. Kind of adjust this for a second. I'm on the bottom of page 12. It's called Lerna's Hydra. And it's a mythical story. You've probably heard of it. You saw the Disney movie with Hercules. You see the fight chance where he fights off the Hydra and chops off all the heads, and they all grow back up again. And then he has to smash it with a rock. Spoiler alert. Sorry, after the fact, not really a spoiler. So what I want to tell you is that we can model the process of the heads growing back by using an exponential function, because when one head is chopped off, two more grow back into its place. So let's presume the Hydra starts with one, like the first time that a sword cut happens. Then we get two. Back. Hang on a second. I mean, starts with one, head chopped off. Then two more grow back in its place. Maybe I'm going a little bit too fast and ahead of myself. I do actually like what I put before. And it's because, I know you're groaning right now, but deal with it. It's because I want to maybe consider that in the beginning, there was only one head on the Hydra, and it was beastly. And then one sword swing later, and head chopped off, and then two more grow back in its place. Two sword swings later, and four heads grow back. I thought it was important to actually go back and consider the zero, like before anything happened. Like an initial value, there was only one head on the Hydra. Three sword swings. Chop. That was too many chops. You have 8. And so ultimately what we're winding up with is, get rid of that. We're winding up with a function where we can describe all the features of an exponential function based upon building a table and analyzing the table and looking for key features. And then completing this generic, completing this exponential function. The function is f for function, but maybe it makes a lot of sense to not say f, but to say the number of heads is dependent on the number of days. So h of n, our hero has chopped off the Hydra's heads every day, and it seems to be a problem that is growing exponentially because. Well, maybe I'm gonna wait for part B to answer it until after I build the formula, because if I build the formula, all you gotta do is plug in 10, and we have our answer, and the answer is correct and good and mathematically calculatable. So h of n equals, okay, remember, an exponential function has an initial value, so that's where we use that from the previous day, and some sort of growth factor, and then it's raised to the power, the variable is the exponent. Exponential functions, the variable is the exponent. And so we're left with, I guess I wrote a 2 ahead of myself. We're doubling every time, so the doubling factor is the 2 in this problem. So h of n equals, on the initial value, worth recognizing, that's the IV. And so therefore it's going to become 1, where A is located, 1 times 2 to the power of, so use a decimal point, 2 to the power of n. And there you have it. That's our exponential model that tells us that by the 10th day, so h of 10 equals, I don't really need the 1, it's just there. You should know that it's always there. I can go 2 to the 10th. 2 to the 10th is a really good approximator for 1,000. 2 to the 10th is 1,024. So, I mean, Hercules has a lot of work to do. He should probably, learn some mathematics and stop chopping off the monsters' heads because they grow back. I think that was a line from the movie as well. Yeah, he did, but down to smash. Okay, all right, well, that completes this problem, I think. Let's go ahead and look at the next day. Swipe. Construct a sequence of numbers. This question's written all out of order. I'm sorry. You're going to deal with the out of order for this time, and then I'm going to replace it for next year. Construct a sequence of numbers that represent the number of heads of the Hydra as they get cut off. So 1 head, then 2, then 4, then 8, then 16, then 32. So that's 0, 1, 2, 3, 4, 5. Okay? Maybe, there you go. Okay, write the formula. We did the formula. We wrote the geometric sequence. I need to go back all that previous page. I'm going to leave it as is. I'm going to say, you know what? This is worth skipping because I believe we did this in the bottom of page 12. And we've written a formula. We'll rewrite it. Here we go. H of h equals 1 times 2 to the power of h. So h of 8 equals 1 times 2 to the power of 8. Ooh, I know this one is. This is 256. Come on, you should know your powers of 2. And there you go. Explain how the structure of a geometric sequence relies on the concept of exponents. Remember, a geometric sequence is where you're doubling every time. There's a growth factor that makes us go from 1 to 2, 2 to 4, 4 to 8, 8 to 16, etc. So in this problem, if we're going to double every time, doubling is an exponential relationship. So whenever we have a geometric sequence is an exponential function. The doubling, or whatever, Latin for all of them, the doubling factor is an exponential change because of repeated multiplication. Exponents tell you how many times you're going to multiply something. So the doubling factor is an exponential change. All right, if you would, that's the bottom of page 13. If you would please do the learning target and success criteria. I can interpret the growth factor. I can model a real world situation. The goal behind those is to help make sure that you are ready for the rest of this lesson, the rest of this concept, and feel prepared enough to be successful on the Smarter Balance. The exit ticket is a great question that once again asks you to create a function. So at the end of all of it, you need some v of n equals initial value times growth factor to the power of n. Hopefully that's enough information for you to be able to fill it out yourself. Alrighty. With that, the problem set is the homework that you need to do. I almost said extra credit, but no. This is the actual homework you need to make sure you fill out. And make sure you're ready for when I come around sometime next week, maybe like Wednesday, and check that you have fully completed every page of Lesson 18, Day 2. Okay, that's it for this video. Go ahead and get ready to go to Lesson 18, Day 3, and follow along, see the video, compare with your notes, compare with your friends, help each other out, and we'll talk to you later. Bye.